Let's go to number 9, right here. We're going to be looking at some more symmetry. All right, so part A, we have a heart. Is there a line that you could fold that heart on that would cut the heart exactly in half?
Down the middle.
Down the middle. Straight down this way. In fact, that's the way I learned how to make a heart in elementary school. They told me to fold my paper, and then I'd cut out half a heart shape, and then we'd open it up. So we have line symmetry here. Is there anywhere else that I could draw a line and cut my heart exactly in half? Nope. So line symmetry, yes, we've got it, and it is one line. What about rotational symmetry? Could I spin this heart around and make it match up with itself? Stopping short of a full spin. Because remember, a full spin, everything has 360-degree rotation. So that's not anything special. If I take this heart and I spin it, is there anywhere that I could stop that it matches up with itself before I get back to where I started? No. If I go all the way around, then it does. But it doesn't have any stops before we do a full circle all the way around. So I would say no to my rotational symmetry. And because it has no rotational symmetry, we do not have to answer order or magnitude. What about the 4-leaf clover over here? Does it have line symmetry? Where could I draw a line to cut it in half? Yep, horizontal, vertical, diagonal both ways. Anywhere else? Nope. Those are the only ones that I can do. So yes, we have line symmetry. How many lines? 4 line symmetry. Do we have rotational symmetry? Can I twist this figure? Yes. Let's look at that one. So I'm going to copy over my shape here. Remember, on the test tomorrow, if you want to use tracing paper, you are more than welcome to use tracing paper. You can use them on more than just these problems. I'll show you as we get into some of the others where we have rotations, how you can use it even when we have the coordinate plane. All right, so I traced around my figure. Tell me when to stop. All right, so there's 1. There's 2. 3. And 4. That's where I started. So we have an order of 4 on this one. Yeah, it makes it a magnitude of 90 degrees. That's absolutely correct. Because we would take 360 degrees. Oh, I wrote the 4 in the wrong spot. Sorry. I should have written that in order. My apologies. We're going to take 360 degrees. We're going to divide that by our order of 4, and that's how we get the 90 degrees for our magnitude. What other questions do you guys want me to go over? Number 2? Absolutely. All right. We're looking at figure 5 for all of these. Which figure in the diagram is a rotation of figure 5? So I'm going to trace over this just like I had tracing paper in front of me. Here's my little leaf over here. Rotational symmetry. This means I'm going to be twisting it. So I'm going to move it down here so I can twist it and we don't see it on top of the other one. Which of these shapes looks like a rotation? 2. Matches up exactly right there. It's a 180-degree rotation. So this is the only one that has the leaf upside down. If I were to keep rotating it here, if I kept rotating this shape, I'm going to get all the way back around to where I have the leaf over on the left-hand side. So this is the only one that is a rotation. Translation. Translation is a slide or a shift. I can even use my tracing paper to help me with this one. So I'm going to trace over this. Here's my leaf on the left side of the stem. A translation, I am not allowed to twist my paper. I'm not allowed to flip it over. All I'm allowed to do is slide it around. So is there any of these? 4. Let's look at that. Yeah, it doesn't match up with 1. Definitely not 2. Leaf is on the wrong side for 3. But 4, it just came straight down. Now, does a translation always have to be like straight down or straight up and that's it? No. Just to the left or just to the right? No, we can go up and to the right. We can go down and to the right. We can move diagonally as long as I don't do any twisting or any flipping. This is figure 4. Part C, which figure in the diagram is a reflection, so a flip over a line? Number 3 looks like it's been flipped, but is it over just one single line here? 1. Figure 1 is a reflection, so I'll talk about figure 3 here in just 1 second. Figure 1 is a reflection. It's folded over that mostly vertical line up here. I don't have a good way of reflecting with my program. Well, let's look at that. With figure 1, we took figure 5 and we flipped it over that vertical line. Is there one single line that I could flip it over and get it all the way down to where 3 is? No. Oh, you okay? All right. If I reflected it and then I scooted it down, that would be figure number 3, but that would be a reflection and a translation. So that would be 2 different things going on. So figure 1 is the only one that I have that is a reflection. So far, so good? All right, what else do you guys want to see? Number 3? Sounds good. Number 3's got a whole bunch of parts to it. And I will say before we get into number 3, if you do not know your rules for reflection or your rules for rotation, you absolutely need to know those for the test tomorrow. I'm not giving you the rules on the test tomorrow. You need to know those. If you don't know them, maybe make some flashcards, work with a partner so that you can remember your rules for how to reflect and how to rotate. We are going to start with point E, this guy right up here. Every single part of this starts from this point. So we're always going to go back to point E, and then we're going to do whatever transformation they have for us in these different questions. Like in part A, we are reflecting across the line y equals x. When you see just a y and an x, and an equal sign in between them, what is our rule? Y equals x. We're going to switch them around. So here's what I'm looking for so that I can try to, because I know remembering all these different rules, we got a lot of different rules here. When I see the y equals x, it has those 2 letters in there. I'm going to flip them around. Because normally in an ordered pair, which one comes first? X comes first and then y. When I look at this equation, which one comes first? Y. So I'm going to remember to switch them when I see y equals x. We don't do anything else to this except switch those 2 numbers around. So the first number I would see is what? 24. And the second number? -5. Reflecting across the x-axis is what we're going to do next. What's the rule for reflecting across just the x-axis? X stays the same. Anything happen to y? Y changes signs. So my E prime, if x stays the same, would be what? -5 for the x part, and what would the y part be? -24. They didn't ask for it here, but what would the rule be for reflecting over the y-axis? Y stays the same and the x changes signs. So whichever axis I'm on, if it says the word axis, whatever letter comes before that, that's the piece that stays the same. When I see the x and the y with an equal sign, normally x comes first. In that equation, y is coming first, so I know I'm supposed to switch them. Rotating 270 degrees clockwise about the origin. Let's make a real quick sketch. I want to see where I'm starting from first. So point E, -5 would be over here. 24 is going to be up real high over here. So E is going to be in the second quadrant. Rotating 270 degrees clockwise would put me into what quadrant? Third quadrant. It's going to come around here. What's my rules for my x and my y's there? Or what's my sign rules? Negative and negative. Do we do any switching for 270? Yes. We're going to switch and match signs. So I'm starting off point E, -524. E prime, I know I have to switch. So 24 comes first, the -5 would come second. And I have to match signs to the quadrant that I'm landing in. -24 and -5, absolutely. What about 270 degrees counterclockwise? I'm going to draw a new picture so I don't have too much going on. We know E is here in the second quadrant. If I go 270 degrees the opposite way, that's going to put me into what quadrant? Quadrant 1. Counterclockwise would spin it here. Tell me about the ordered pairs in quadrant 1. They're all positive. Do I do switching for 270? Yes, so same idea. We're going to switch and match our signs. So what would E prime be then? +24, +5. Rotating 90 degrees counterclockwise about the origin. 90 degrees counterclockwise is exactly the same as what? Yes. This is the same as 270 degrees clockwise. Didn't we already do 270 degrees clockwise? Which one? Yep. Because remember, 270 counterclockwise is the same as 90. I wrote 270, sorry. I should have written 90. I was looking at the problem. Kaylin, I'm sorry, what did you say? -24, -5. So it's exactly the same as part C that we already did. Counterclockwise would rotate me right here. Oh, no, I had that written right the first time. Good grief. Same as 270. 90 degrees counterclockwise is the same as 270 degrees clockwise. -24, -5. Remember, 270 and 90. We're going to land in the same spot. They're opposite directions. So if I don't want to go 270 degrees as I'm spinning, I can go 90 the opposite direction. I'm going to get the same ordered pair. What about 180 degrees? Let me draw my sketch. E is over here in the second quadrant. 180 degrees would put me into which quadrant? Quadrant 3? That one right here? Are we going here? So which quadrant? The one right next to it. This is quadrant 4. I don't expect you guys to know the names, so if you mix up the names, that's not a big deal. 180 degrees, doesn't matter which direction we're going. What are my signs looking like in that quadrant? Positive x, negative y. Do I reverse the order when it's 180? No, this is going to be same order as original point. So my point E prime, if it has the same order as my original point, well, that had a -5 here and a positive 24 here. But now I have to make it match +5 and -24. We always have to match our signs. All right, before we do this last one, before we do part G, I want you to stop and look at all of our answers so far. Every single ordered pair has the number 5 in it. Every single ordered pair has the number 24 in it. Sometimes they're positive, sometimes they're negative, sometimes they're switched around, but there's a 5 and a 24 in every single ordered pair. When I translate, so when I'm mapping one point to another using a rule that looks like this or using a vector, I'm not going to end up with an ordered pair that has a 5 and a 24 in it. Rotations and reflections, unless it's a reflection over like x equals 2, we're going to keep the same two numbers. All right, so I'm going to start off with my original point E, which was -5, 24. What does the rule tell me to do to the x's? Add 11. So I'm going to plus 11 to the x here. Which way would that send me? To the positives. Would I be going left, right, up, or down? Right. This is right 11. What are we doing to the y's according to this rule? They're going down. We're going to -9 from the y. And that's going to give me my new ordered pair, my E prime. So -5 plus 11, what would that be? That's going to be a +6. So E prime is +6. And then what about 24 minus 9? +15. Notice this is the only one that's profoundly different from the ones that came before it. Two very different numbers. The only other time I can get two very different numbers like that by doing something other than a translation is when I'm reflecting over a y equals a number or an x equals a number. Yes. Yes, I do. What else do you guys want to see? Marco? 7? All right. Let's go look at number 7. Here. First thing we need to do on number 7 is graph that original line segment. So we're going to graph points A and B, and we're going to draw the line segment in between them. So A is -1, 8, way up here. And B is -5, 6, right over here. And then I need to connect those. You guys will absolutely have straight edges tomorrow. We're going to translate along, and then it says -4, 2, and it's kind of hard to see, but I do want you guys to look closely. These are not parentheses. These are angled brackets. It tells me I'm translating here, so I know I'm going to be shifting. What does the first number in that ordered pair tell me to do? Go left 4. So I can either come over here to my graph and I can count to the left 4, or I can go to my ordered pairs and I can minus 4 from the x parts of each of these. What does the next number in this vector tell me? Up 2. The first number tells me about left and right. The second number tells me about up and down. So I could come over to my points and I can go 1, 2, 3, 4, and then I can go up 2, and I could put my ordered pair down for B prime. Or I can add 2 to the y's after I subtract 4 from the x's. Let's see, if I do -5 minus 4, what would that be? -5 minus 4. -9. What is 6 plus 2? 8. If you look at where I got just by counting left 4 and up 2, I landed at -9, +8. So you can do it either way. What about for A prime? -1 minus 4? -5, and 8 plus 2? 10. So -5, 10 for my A prime. Way up there. Part C, we're going to take A prime, B prime, that blue line segment that I've got up at the top, and we are going to reflect that across the x-axis. If you want to use tracing paper for this, you can. You could put tracing paper on top of the graph. I would trace on top of the x and y axis, and then I would trace in the line segment that I'm wanting to reflect. And I'd fold it on the line that it says to reflect on and see where that falls on my paper then. Does anybody remember our rule for reflecting over x? Yes, x is going to stay the same, and y's are going to change sign. So for A double prime, x is staying the same, y is changing sign. What would A double prime be then? Be -5, and it's going to be -10 because my y's are going to change signs. So -5, -10. My A double prime is way down here. Where would B double prime be? -9, -8. So right here for B double prime. And then I would connect those two together. What else off the review do you guys want to see me work through? $11. Sounds good. Number 11. We're just going to put one single word on the lines down below. We're either going to put the word translation, we're going to put the word rotation, or we're going to put the word reflection. I'm not asking you to tell me how much we're rotating by. I'm not asking you what we're reflecting over. A translation means a slide, right? If I wanted to check for a translation using graph paper, I'm going to copy my shape onto my graph paper. And then I'm going to slide it and try to make it match up with that other shape. Is this first one an example of a translation? No. Is it a rotation? Is it a twist? Can I twist it and make it match up? No, I can't make it match up with the other side over there. So if it's not a translation, it's not a slide, and it's not a rotation, this is a reflection. If I wanted to be all kinds of fancy, I could say that it's reflecting over this line right here. Notice D and D prime are both 1 unit away from that dashed line. C and C prime are both 3 units away from that dashed line, so that's how we do our reflecting there. Let's come and look at the middle one. So I'm going to trace over this shape. Can I slide this on the page and make it match up? Yes. Technically, I should have started with the bottom one, but either way, that is a translation. Notice I didn't flip or twist my paper at all, my tracing paper. I'm using my virtual tracing paper. This particular translation is going to the left and up, but translations are allowed to do that. So it ended up being like a diagonal translation. That's okay, as long as I don't twist it, as long as I don't flip it. All right, process of elimination tells me this last one would have to be what? Rotation. Let's look at it. So I'm going to trace over my triangle ABC. B is up here at the top. A is in the lower left. C is in the lower right. I can take this shape and I can twist it until B and B prime match up. Notice C and C prime are matching up, and A prime are also matching up. This rotation is not around the origin. That's okay. Not until do lunch. So we've got 10 more minutes. What else do you guys want to see? Which one? 10? Absolutely. Let's go look at number 10. I really like this one. This one was one that people had a lot of questions about yesterday as we were doing the stations review. There's 2 different ways you can do this one. You can look at the graph and you can count between the points, or you can do it with ordered pairs. I'll show you how to do it both ways. You pick the way that you like the best. For both of these methods, I have to pick out points that would match up together. So like M and M prime, those match, or N and N prime, or L and L prime. I just have to pick 2 of them with the same letter. You guys okay if I go with the M? Whichever one does not have the prime, that's the point that I'm starting at, and I'm moving towards the one that has the prime with it. The first number in my translation vector is going to tell me about left, right, up, or down. Left, right. If I am going to the right, what kind of number will I see here? A positive. What about if I'm going to the left? Then it's going to be a negative number. As I move from M to M prime, am I going to go left or right? Left. How far left? 5 units left. So how would I represent that in my translation vector? -5. What about the second number in the translation vector? What's that telling me? That tells me up and down. If I'm going up, it's going to be a positive number. If I'm going down, it's going to be a negative number. All right, I've already shifted M 5 units to the left. Do I go up or down from there to get to M prime? Down. How far? 2 units, so 2 units down. And I represent that with what? -2. There's my translation vector. All right, I promised you 2 ways to do this. I'm going to show you the other way to do this. I need ordered pairs for the other method. The one without the prime, I write first. Where's my point M at? 3, 1, 2, 3, looks like 3, 4. Then I'm going to leave some space. That's where my vector would go. I'm going to put an equal sign across the bottom. And I'm going to write the point that has the prime with it next. What's the ordered pair for M prime? -2, 2. All right, we're going to look at the x's first. Here's a 3. What would I do to that number 3 so that I end up with a -2? 3 and then add something to it or subtract something from it, and I want to end up with a -2. Subtract. How much would we subtract from a 3 to get a -2? Yeah, we're going to subtract 5 from that. Notice that's the same thing that we got by counting when we counted to the left. Let's go look at those y's now. Here's a 4. After my translation vector, we're going to end up with a 2. -2 or -2. So I get the same translation vector whether I do it by counting on my graph. First number is left, right. Second number is up, down. Or I can do it with my ordered pairs. We're going to figure out what that piece in the middle would have to be. So far, so good? As long as we're on this back page, you guys okay if we go do number 12? Let's look at number 12, since we're right there. We have a triangle with vertices S, T, and U, and we're going to reflect that over the line y equals -x. Well, for the other one, when it was y equals x, we said the rule was to do what? Switch them. When it's y equals -x, I'm still going to switch them because the x and the y are reversed, but I also need to do what? I need to change both of my signs. So we're going to switch the x's and the y's and change both signs. So these original ordered pairs, everybody's signs get switched, so these guys become positive. This one's a positive, that one's a negative. And back here with you, they would both be negative. And then I have to reverse their order. So where's S prime then? +2, +3. Yep, remember we switch them and change their signs. What about T prime? -3, +2. And U prime's the easy one. -2, -2. All right, we still have 7 minutes before the end of the period. That's time to do 1 or 2 more depending on how long they are. Number 5. We're going to graph and label this figure and its image. So my original figure is triangle CDE with these ordered pairs. So -2, 2 for C. -1, 4 for D. And -6, 3 for E. And then I'm going to connect those. Get my triangle CDE. All right, what are we doing in triangle CDE? Rotating it 90 degrees clockwise. That's going to send me into what quadrant? Into the first quadrant. 90 degrees clockwise would be this way. Tell me about the x's and the y's over there. They're all positive, so positive, positive here. Do I need to switch my ordered pairs? Yes. So we're going to switch and match signs. We said everybody's going to end up positive. So when I switch C around and I make everybody positive, C prime would be where? 2, 2. Let's go graph that. 2, 2, right here. There's my C prime. Switch the order pair around on D and make everybody positive. So D prime would be 4, 1. Let's go graph D prime. right there for my D prime. And then what about for E prime? We're going to have +3, +6. I'm going to come over to my graph. +3, +6 puts it right up here. So here's E prime. And then I'm going to connect those using my straight edge. And there is my rotated triangle, C prime, D prime, E prime. I still have 4 minutes, which is enough time for one more problem at least. 8, absolutely. All right, so on problem number 8, we're going to start off by graphing points G and H. Nope, it's a rotation. So we're taking this and turning it like this. So E is going to twist up like this. I know, it feels weird. G, right here, 3, 2. And H, 4, -5. Grab my straight edge and connect those points together. We're doing 2 transformations to this one. The first one that we're going to do is a rotation of 180 degrees. Are my points both lying in the same quadrant? No. So when I rotate them, they're not going to the same quadrant because they didn't start off in the same quadrant. If I go 180 degrees, do I switch the order of the numbers around? No. Same order as my original point. But we're going to have to match our signs. So I know for G prime, the 3 is still going to come first. The 2 is going to come second. I don't know whether they're positive or negative yet, though. And for H prime, the 4 is going to come first. And the -5 is going to come second. But I don't know if they're going to keep those signs. Let's look at where point G goes. 180 degrees would send point G into what quadrant? It's in the first quadrant right now. It's going to go into the third quadrant. So it's coming down here, which is a negative quadrant. We already kept our order the same, so what do I need to do to both the 3 and the 2? We're going to make them both negative. So -3, -2, right here is my G prime. H is not in the same quadrant as G was. H is down here in the fourth quadrant. So when it rotates 180 degrees, it's going to go into what quadrant? Into the second quadrant up here. Tell me about the points there. Negative for the X's, positive for the Y's. So that means it has to be a -4 and a +5. Right here would be my H prime. I'm going to grab a straight edge and connect those two together. All right, so there's my first transformation. What else do they want me to do? Reflect over the line x equals -6. What kind of line is that? Vertical line. The way you remember this, it's going to have to touch the axis that it has the letter. So x equals -6. It has to touch the x-axis. So that would be right here. It doesn't have a y in the equation, so it is not allowed to touch the y-axis. So it has to go like this. There's my x equals -6. Do I have rules for this kind of reflection? No. How do I get my points then? Count. How far away is G from that line that we're reflecting over? Sorry, G prime. 1, 2, 3. So on the other side, 1, 2, 3. Right here would be G double prime. What's that ordered pair? -9, -2. How far away is H prime from that line? 2. 1, 2. So we go 1, 2 on the other side. Right here is my H double prime. And what is that ordered pair? -8, 5. All right. Nice work today, guys. Answer key is already posted for this. If you haven't already, please make sure to turn in your warm-up today. You'll be turning in this review tomorrow before you take your test. To get to the answer key on Canvas, you have to go to Modules and find Today. And then you have to click on the page. So you have to click where it says Review Day 2 and scroll all the way to the bottom of the page. That's where the answer key is going to be. I am posting videos for first period and second period and 7th, 4th. I had some technical difficulties, wasn't able to get a video for that one. But if I did not go over one that you have a question about and you don't have a chance to get that answered, maybe check out those other videos. All right? Good luck on your test tomorrow, everybody.